All right, yeah, welcome back again. Want to look at today, want to look at a discriminant function or discriminant function analysis. And it's one of the classical techniques of multivariate statistics. Right? It actually examines the separation between two groups of observations. Right? It's different from a canonical variate analysis, which you're going to see later, because that one, this one deals with two groups only, though it could do more than two groups, but it will analyze them differently. All right. So it is a very crucial function under MorphoJ, because it also helps you to get what is called confusion matrix. All right. So you can actually use also use a leave one out cross validation in between to see a better result, even though a more rigid result. Okay, because the result is more strict in when you introduce a leave one out cross validation, but it's more it's better than the direct discriminant function. So it gives you the chart, which is the graph. It gives you the shape, combined shape, which is a uniform or mean shape of the group. At the same time, also gives you the result. All right. So here, basically, we have our database here, which we have brought in before, if you still remember. So I'm going to be using the first one, sex here, DB sex. It has two groups. So it has a male and female. So according to what we have analyzed so far, so I'm going to be bringing in, using it to generate the what is called the discriminant function in this section. All right. So when you want to do that, just select this DB sex. Okay. Select. Then go to comparison. Click on discriminant function. So here you can give it a name you want. Let's say discriminant function -1. All right. Then here you already show, because you have selected DB sex, it's shown here. If you don't want to change it, you can open it and change it here. Right. So now this is our classifiers now. So because we want to classify as well, like when you are doing machine learning, you want to predict, all right, the accuracy. So we will not get the exact accuracy, but we get a confusion matrix. Then we can calculate accuracy from there. Of course, you know how to do that. So now we click on pair, go to pair by sex, all right. So this is our pair of groups to be included. So select this, okay. So we can say, okay, include the pair of groups, and if you like, you can now permutate. Okay, so let's permutate as well. The default is 1000. If you want to increase to make it better, you can increase it maybe to 10,000. Okay, all right. So let's just run here. We click on execute. So what do we have here is basically uniform shape first. So you see loading, you see running. So that one is done. So you see running. So you can just flip this to come. So this is the uniform shape of male and female combined together, in case you need it for explanation in your report. So, but we have a discriminant score here. This is well separated, so you can change this color if you don't want to. I've shown you how to do that, so you don't need to just right click on it and do and change it. Okay. So and then we can see here this frequency is male female. So this is female, this is male. So you can see both of them here. Now, if you look at it critically, you understand that it has a cross validation as well score, which is that is more stringent. You can see that it's more stringent. So it's not as separated as a normal discriminant score we have here. Okay, so you can see there's some overlappings here. You can see that. So it's more stringent than the normal discriminant score, even though it have a better accuracy than the discriminant function. So let's look at the result they gave us now. So go to your result now, click on result. So you can see the result here. So it gives you ultimate question analysis. This is the name we give it. So the difference between we have a postcode distance here, okay, 0.067. Then we have Mahoney distance as well. We have our t-square and their p-value 0.001. This is less than 0.001. Significant. We have a p-value for permutation. So because we did permutation, we have for postcode, we have t-square for permutation as well. So they are both significant. All right. So note the permutation test using the t-square statistics is equivalent to a test using random distance. So that is just giving information. So now let's look at allocation, miscalculation now. Here we have our group 1 is called female, group 2 is called male. So take note of that. So whenever you see group 1, we are talking about a female, group 2 is male. So this is our confusion matrix for the signal function. This normal design function, we have confusion matrix here. The total is 60 for each of them, each observation. Now here we have 57, 3, 357. So here you can find, by looking at this diagonal here, you can find your what is called your positive, and you can find your negative. So here you can calculate your your accuracy here using this now very easily. Is that correct? Yes. So just mean this the diagonal all about the total. So you understand that. Then for cross validation now, you can see that this one is more difficult, is more stringent. So if you calculate here now, you see that it's very small. Your accuracy is very small here, while here is very high. You see that. So you can choose to if you have enough data, I think this may increase, or you can permutate more by using 10,000 instead of just 1,000 permutation. I don't know if you can. Let's try one more time and see if I can increase it. Let's recreate it afresh. Okay. Let's say we want to create another one. Let's say we cross that function. We now say okay, sex. Okay, include relation permutation. Let's say 10,000. It takes some time before it executes, so you have to wait for a while because it takes a lot of time. Let's see the difference in the result, if it's going to be better than the former one we did before. So it's loading now. It takes some time to process, so you just have to wait for it to finish. The previous one was 1,000 permutation. This one is 10,000 permutation. So you can see the difference now. It's going to take a lot of time, but nevertheless, we still wait to see the result and what we get. So is it giving us this shape here? Okay, it's giving us almost same. I don't see any much difference. I don't know if you can see some difference in the score, but I mean the result. But looking at the shape here, I'm not seeing any difference in the cross validation result. So it's finished. So let's see the result. If a little bit different from the previous one. So here we have 53, we have 33 and 57. Here we have 41, 19, 19. Let's see if there's any difference between the two. All right. So this one is same, and this one is also the same. So you can see no difference, even though we increase the permutation, no difference. All right. So that is that for now. So you can just calculate your function matrix from here using this particular one. If you want, then you can now get your signal function out. You can just export out. Okay, this one you can put in your report. You can change the color. If you don't want this color, you can change it. All right. So color by group. So it's very easy. Can you see? So just change the color. If you don't want the color, use a different color here. All right. So maybe you want blue. Okay, you can say use color. So you can see it has changed. So that's a male. This one's female. So that's all about that. So it's very easy to compute here in MorphoJ. So that is that for now. I will see you in the next one. Thank you so much.